Okay, I think we should be at the start now. All right, so we have an exciting session ahead of us. So we have the V7 upgrade coming in a week or two, and this upgrade comes with 4 new modules: the callback module, the cwfees module, the ICA module, and also the errors module. So Spoorti is going to be giving us a detailed presentation on the V7 upgrade and also digging deeper into these 4 modules and how they'll be very useful to developers going forward. So Spoorti, are you ready?
Yeah. Am I audible?
Yes, I'm hearing you. So you can share your screen if you need to as well. So the floor is yours.
Okay.
Yeah, I'm seeing your screen.
So, as Adrian mentioned, Ashray V7 is going to have the 4 modules. We're going to go kind of deep into what each of these do and kind of some examples on how contract devs can use them for their various purposes. So the first one is the callback module. So the purpose of the callback module is to allow customers and smart contracts to receive callbacks. And this happens at the end of every block after all the transactions for that block have been finalized. This is useful for doing things which need to happen at a specific time. And fundamentally what this means is that usually right now, any smart contract interaction can be executed either by a user with a private key or by another contract. And this module allows the protocol itself to execute things at your contract. So this could be useful for things like vesting distribution or auto-compounding of rewards. And in the case of Archery, if your contracts are gaining quite significant amount of contract rewards and you want to withdraw them frequently, but you have to do it manually right now or use some sort of trusted third-party bot scripting solutions. Now you could just use callback where every 1 month or something, all your contract rewards are automatically withdrawn. And traditionally, whenever you're executing a transaction, it's the user who is paying for the transaction fees. But since executions with the callback module are executed by the protocol and the protocol does not pay for transaction fees, this could allow for misuse of this feature. And that is why when you want to register a callback for your own contracts, you have to pay the transaction fees in advance. So every callback has a maximum amount of gas that it can consume, and we charge the transaction fees for the max gas amount. And eventually, once the execution is completed and any gas is left behind, and those transaction fees are going to be refunded. And we also have reservation, 2 types of reservation fees as well. One is the block reservation fees. This means the more number of callbacks there are in a certain block, the more fees you have to pay for that block. And the future reservation fee is the more far ahead in the future you want to register a callback, the more you have to pay. So if you want to register a callback 2 minutes from now, it's going to be much cheaper than if you want to register something 2 weeks from now. And now let's look at some contract examples of how this works. So first, to register a callback, you can use the CLI. So you provide the contract address, which needs to get the callback, and a custom given job ID. This is quite similar to how the reply entry point works on Plasm already. This is just so that the contract is aware of any context regarding the callback. And then you provide the callback height for when you want to receive this and the fee amount, which was discussed in the previous slide. So you can do this via CLI, or you can do this via Stargate messages within the Cosm contract itself. So once you have registered a contract and for X number block, and now it's that block, at the end of the block, the pseudo entry point in your callback in your contract will be hit. So we will also pass in the job ID, so your contract will know what to do and how to do. So if you want more information on On this module here is the ADR and the module spec. And in case you have any questions about callback, you can ask now or maybe wait to the end as well. And so the next module is cwfees. Now, the point of cwfees was to kind of change how transaction fees are handled in the ecosystem right now. Because right now, either you pay for your own gas fees or you use the customers as the case fee grant module where some other account pays for your behalf and they have a certain degree of restrictions on which messages they're willing to pay gas fees for, etc. But the way the fee grant module works is, first of all, it's dependent on Cosmos SDK. So innovation happens quite slowly at like once every few months, a new feature might come out. But you as a tap dev might want to make things a bit faster. And this module allows any Cosmos contract to be a fee granter in itself. So this means if you want to update your project, you can do that at much more frequent level and than you would if you were using the fee grant module. So how this works is the contract needs to do a register as grantor Stargate message. They need to send a Stargate message to the chain. And once that has happened, people can use the contract address as a fee grantor. So when a user is using your contract as a fee grantor, this pseudo entry point will be hit. And this information, this entry point will also give you the information about fee requested, which is how much amount this person was to use as fees. And also what are the messages which are within the transaction. And within each message of the transaction, who is the sender, what is the message type, and the actual message binary itself. So this means that you could have conditions where you have a hard limit on how much fee you're willing to pay and how many messages you're willing to pay for. So let's look at a sample of how this would work in an actual contract. So in this example, we have a situation where this particular code is going to allow a whitelisted addresses and a bunch of whitelisted contracts with a specific message type. And it will only pay fees for those, and then all these three conditions are met. So the first thing we do is we only want to pay fees for Cosmos as an execute contract message. So we start looping through all the messages now, and then we see who's the sender. And if these senders are whitelisted, only then do we proceed ahead, else we are not willing to pay the fees for these users. And then once the users have been checked, then we check if the message URL matches. In case they have trying to use some other message, then this does not work. And after that, we unmarshal the execute contract message, and then we see the contract address. And if they're using any whitelisted contract, then we pay their gas fees, else we do not. So as you can see, since the contract has access to the entire transaction message list, this allows for very robust solutions. So you could even have more details on this. You could have message.actual binary blob. You could unmarshal that, and based on the actual input of what they're trying to do, you could either provide fee grant or not. For example, if some user is fine, if this is an NFT contract, for example, you might want to provide fee grant for minting, but not for transfer. So you could have explicit logic based on what the user is trying to do, and then accept fees for that or not. So in case you want to get more info on how the CW fees works, here is the ADR. I just added that in the chat. So let's move on to the next module, the cwica module. So ICU was already available for Cosmos on our space since launch. But the way it worked previously was the devs would have to understand the entire life cycle of IDC and implement all of the entire life cycle changes. But from Azure v6, we enabled native ICA, but that was only at a user level. So now for Azure v7, we are integrating ICA, but with a middleware which is dedicated to be used by Cosmos. So how this works is, so let's say you want to register an interchain account. For this example, let's use you want to create an ICA on osmosis. So if you're a contract, you just need to create a register option where you provide your current contract address and you provide the connection ID of osmosis on Austrian mainnet. And then you just encode that as a proto message, and then you send it as from the add message in CosmOsm, and this will get committed to Archway, and then the relayers will pick it up from the module, and then this will go and get executed on Osmosis, and then the relayers will send back the message that the ICA was successfully created, and then you will get a callback on your contract under ICA, and the account register field will be filled with the counterparty address. So in case Osmosis, this will contain the Osmo address. So now the contract will know that the ICA account registration was successful or not, and if it was successful, what the address is on the other side. So now that you have an ICA account, if you want to do something with it, so in this example, we're going to vote on the other chain. So this is quite straightforward. You use the Cosmos SDK proto crates, and you can create a message vote type and then wrap that in the proto encoding as well, and then put that inside the message send TX. And you have to ensure that you're providing the ICA address, that is the Osmo address, which we got from the previous callback, and then provide the accurate connection ID and a custom timeout, and then wrap that in a Stargate message and send it along. And now this will get picked up by the relayers and then sent to the Osmosis chain, and then it will be executed. And once the vote is successful, the relayers will get the message back, and then you will get another callback under ICA, but TX executed. And this will in turn contain a binary data response, because this has to be abstracted away because we don't know what message will actually be executed. You can even send multiple messages within the same ICA send TX as well. And yeah, so this basically concludes cwfees. The main intention of building this module, instead of using the existing ways to do ICA, was to abstract away all the IBC, ICA stuff, so that the contract devs only have to worry about the actual interactions and not worry about what is the management of the IBC channel and ensuring things are connected, and in case the channel expires, and those need not be worried upon by the devs now. So next we will come down to cwrors. And so right now we have talked about two modules, callback module and cwsa, both of which have pseudo, who take advantage of the pseudo entry point. And the thing with pseudo entry point is it's the protocol which is executing these things, not an individual user. And that means in case there's any error which occurs during any of these executions, the contract will not know that this happened, the user will not know that this happened. Only the protocol will know, and there needs to be a way for the protocol to let the contract or that dev know that this issue occurred. There could be many issues depending on maybe the endpoints were not implemented. Maybe in case of ICA, you tried to vote on a governance proposal, but then the governance proposal does not exist, or the voting period expired by the time you voted. So this is going to cause errors, and now the contract needs to know that an error has occurred. So that is why we use the cwrors module. And the way it works right now, anytime a contract encounters an error in the callback module or the cwica module, this will get stored by cwrors with this data structure. So we'll store what the module name is, we'll store what the error code is, and you can see what the error codes are on the right side here. So callback module exposes two error codes. The first one is in case you run out of gas. The second one is in case there's an execution error. For cwsca, there are two error types as well. One is the packet timeout, and second is in case an execution failure happened on the counterparty chain. And yeah, so the following information will be stored regarding each error for the contract. One is the module name, error code, and the relevant contract address, and what the input payload was, and what the error message is. So based on the module name and error code, you should be able to unmarshal the input payload as well as the error message. So with all this information, you will know, as a dev, you will know how to deal with the errors. But right now, these things are just stored in the module state. So when you need to proactively go and check if an error has occurred and what to do about it. So you can just check it via the CLI, or the contract can check itself via Stargate queries. But this still means that at some point you have to go and keep checking if an error has occurred and then react to it. So we implemented a subscription service on the module where you subscribe to error callbacks, and there is a fee amount to be paid for this, and this is a governance controlled parameter. And when you subscribe to the errors, anytime an error occurs, whether in callback or cwica, you will immediately get a callback at this pseudo entry point, where you get all the same information, which is available stored in the state. So here is a sample on the right side where you can see, you check what the module name is, it's cw.ca, and in case of error code 1, then we know it's a packet download error. And for example, in ICA, when there is a packet timeout, because ICA happens with older channels, that means the channel automatically gets shut down. So in this case, when you know that this happened, you can use this to reopen the channel by registering the ICA. This ensures that the ICA channel is always open. So this allows you to smartly react to any errors. And yeah, so you can have, so all the modules, like right now we just have 2 modules which use CW errors, but eventually we have in the roadmap other modules as well, so they will also be using the same thing. So as long as you implement this, you should be able to handle any errors. And especially if you're using callback or cwica, we highly recommend having this implemented as well. Or even if you do not have them implemented right now, it's better to have this, because we plan on adding new protocol features, and it will always be any protocol executed errors for contracts will always be hit upon over here. So so in case you want to get more details about the errors module, the ADR inspect, I just posted it in the chat. And that's about it. I can take any questions now.
Thanks, Spoorti. So I have a quick question for you. I have a scenario. So I'm working on a side project, right? It's an NFT game with various assets, and you need to feed these assets. And one feature is allowing a user to feed their asset in the future. So, for example, if they want to feed the asset for the entire week, and transaction would need to be executed at specific times throughout that week. And I see this use case being useful for the callback module. But what would happen, like, if for one of those callback transactions it errored out? Would the contract be able to, at that specific time, query to see the error and then do a fallback? So the error module. So if because nobody is actually at their computer at that particular time executing the transaction, so this is done via the protocol. So what recourse would be possible to prevent the loss, or to ensure that that particular transaction gets through?
Yes. So let's say you have a callback for the week where you're feeding your asset, and in case an error happened, so the default behavior is that the CW error module will just store the information. It will not do anything with it. So in that case, something goes wrong, you have to kind of be proactive and check if something went wrong. But you could also, because we also expose the error details via Stargate queries, and if this feeding of asset is something you do frequently, so if you have a callback schedule for every week, you could do it so that before you feed, you do a Stargate query to see if there are any pending errors. And if there are pending errors, you deal with that. If there are no errors, then continue with the feeding.
So it's not possible to check the errors as they happen. So, for example, if something happened where an error is generated from that callback transaction, the contract wouldn't be able to query that error immediately and then try to execute a fallback, or it would have to wait.
Yeah, so immediately
I
think, yeah, Adrian. Yeah, so when in case an error occurred, the callback execution is now complete. So what you can do is, if you have a contract and you want to subscribe to the errors callback, this is a different type of callback. So even in case the callback module thing failed, you could still use this. So this is executed at the end of the block. So it will have a list of all the errors which happen in that block. So yeah, in case the feeding of the asset failed and you have a subscription to this, you will get to know this happened in the very same block itself. So you can deal with it then.
Okay. All right, the floor is open for any question. So another question I had was in regards to the ICA implementation. Is it required that the chain interaction must, or the other chain that you're trying to interact with, must have CosmWasm enabled?
No, this is not required because now we're using the native ICA. So you could do this on Cosmos Hub, even before the CosmWasm yet enabled. You can do this on Akash network or any network. CosmWasm is not a limiting feature anymore, as long as they have the ICA host module enabled. And this is something you need to pay attention to if you're planning using any specific chain, that one, they need to have their ICA host module enabled. And the host module has a whitelisted list of message types that it supports. So, for example, Chihuahua supports all message types, so you don't have to worry about it. But if you're trying to connect with Stargaze, they have like a whitelisted set of addresses where they only allow like bank transfer and staking and delegating. They don't allow contract execution, for example. So in that case, you cannot use ICA to execute contracts on Stargaze, but you can still use it for staking and governance voting and those things. But in case you want to do it, you can always just create a governance proposal on the counterparty chains to enable these features.
Okay. And could you go back to that the callback screen? You had the registration fee calculation. I was thinking, like, is it possible to? Well, more than likely it would be for the DApp to require the end user to, or your stream is closed.
Yeah, it's just like
Yeah, so registration fee, transaction fee for more gas, plus block reservation fee, plus future reservation fee. So block reservation fee plus future reservation fee. So I should be able to, so when generating the transaction, at least the fee for the transaction, I should be able to add this registration fee to that as well, right?
Yeah, so there is an endpoint R3D to estimate callback fees. So that will give a fee split as well as the total fees you need to pay. So you can just take the total fees from that query and then add that in.
Okay.
So you don't have to split the fees when you're paying it.
So the current minimum consensus fee plus the registration fee, and so those are, would that new endpoint include the minimum consensus fee?
Yeah, yes. Okay. And right now we're planning on going to mainnet with block reservation fee to be 0. So all of these will be controlled by governance parameters for the module. So we can always increase and decrease this.
So I'm seeing for transaction fee for max gas. So what's the max number of trans are callbacks that can be executed in a block?
So these are also governance control parameters. So right now, the max gas which can be consumed by a serial callback is 150,000. But again, this could be increased and decreased by governance, and the max number of callbacks in a specific block is right now hard coded to 5, but that too can be controlled by governance. And in the future, we don't allow the callbacks to be registered indefinitely in the future. There is a limit of 21 days right now. This is just to ensure people are more responsible when they're registering callbacks and they're not doing it for like 10 years.
Yeah, because it will be difficult to predict the fee. So what happens like if the registration fee is calculated at a, well, you don't account for token price, but if the current minimum consensus fee increases within that period, then maybe the registration fee calculated would not cover the full transaction fee. So what would happen in that case? The transaction would fail.
No. So in case the minimum consensus fee goes down, then the extra fees is returned back to the person who registered the callback. But in case the consensus fee goes up and the fees are not enough, in that case, we still pass the transaction, and the any transaction fee loss is just swallowed by the protocol.
Oh, so the protocol takes care of that. Okay. That's interesting. All right, so are there any other questions? Let me check the chat because I didn't check the chat. Hi, please kindly provide insight in this domain. Let me check on this. Oh, for example, I think that's...
But can I ask?
Go ahead.
I'd like to understand that I can implement that, my debt. I want people to earn part of institution and see it as one kind of contract, and people collaborating their inspiration. So can you collaborate there? So for example, I would need the smartphone part is the different reward and then copy tree. Is it possible to make this kind of benefit in callback?
Were you able to hear that clearly, Spoorti?
Yeah, I'm sorry, I could not hear it clearly.
Could you go again, Tori?
Do you hear me well right now?
I'm hearing you a little better now.
Hello?
Yeah, I'm hearing you a little better now.
Yeah, cool. I just want to use callback to distribute the reward that accumulated on the smart contract in the end of each week. Is it possible to use callback for this?
Yeah. So you can use callbacks which register other callbacks. So you could set up like a cron job sort of thing you want. So every week it can do something. So you, for every callback, you do your whatever logic you want to do, and at the end of it, you register another callback, so it keeps going in a daisy-chained way.
Cool, thank you.
Spoorti, it would be good if you could give some use cases for each of the modules. Like I think you listed a few, but if you could give a few core use cases, especially for the callback module.
Yeah, sure. So one easy example for callback module is the auto restake. Like right now, the restake app uses the auth module where you give auth permissions to your validators and then they restake on behalf of you. But at the end of the day, you're trusting the validators with it's very limited, but still you're trusting the validators with access to your account. from now, if you want to use the callback module, you don't have to do that. You just trust yourself. So this allows trustless auto restaking of Arch. And in fact, you can combine the callback and cwica to enable auto restake not just on Archway, but on all Cosmos chains. So you can use a callback which triggers an ICA transaction on Osmosis so that your Osmosis account is restaking automatically as well. And then things like, for example, ArchID has domains which expire after a year or after 2 years. So you could use callback so that it automatically gets extended when it's about to expire. And even for things like multi-sig interactions, where usually you have a multi-sig proposal which is voted on by everybody, but at the end of it, somebody still needs to execute the proposal. So you could have a callback such that at the end of the voting period, the proposal is executed in case it has passed.
Hold on, Spoorti. So when I create a proposal, you're saying that I can execute a callback within that proposal?
Yes. So when you create a proposal, at the end of it, add a message that could create a callback for the block where the proposal is voting period ends.
Okay.
So when the voting period ends, the callback will check if the proposal has passed or not, and if it has passed, it can just execute it.
Okay.
And another use case is if you are building any sorts of marketplace and you want to have any form of auctions, then callbacks can be used for options as well, so that it automatically settles at the end of some block. And in case of like DeFi stuff, you could do automatic liquidation in loans. You could do price balancing, arbitrage, all of this stuff which needs to be frequently handled, and you don't want to use any existing script. You could just do all of this on-chain on the protocol. And and as I mentioned with the Archway contract rewards, you could enable so that it automatically gets withdrawn. You could even set it up so that you are automatically withdrawing only when you have more than 1,000 Arch or 10,000 Arch. So this is regarding the fallback module. And for cwfees, basically this allows for very comprehensive way to ensure your users are only accessing your fee grant under very specific circumstances. Because right now, if you want to do fee grant for customers and interactions, you have to whitelist the entire contract execution, which means some other DApp can use your fee grant and use your funds to pay for their users. But now you can pick and choose. You can do explicit executions which have, for example, if your DApp allows for like trading of any CW20 assets, you can have a fee grant which says, I will provide the fee grant only when the asset is worth more than $100. And if it's not, then I'm not going to provide any fee grant. Or you could even have like a subscription service for your fee grant contracts. You can even extend upon this to have like some sort of rate limiting, or you can even use non-Arch tokens as well. So your users provide fees in your CW20 token, but then you in turn provide the Arch token using the fee grant program.
Quick question, Spoorti. So based on the example that you showed, there's a particular specific endpoint that you would, so that pseudo message CW grant. What if I wanted, what if I had an endpoint to feed an asset, for example, and I would want to actually determine whether or not to pay the fee based on whatever criteria I choose? Can I do that as well without it having to go through this particular CW grant endpoint or entry point?
So here there's three questions which is of coin type. We don't specify if this has to be Arch. It could be an IPC coin type as well. And you could say somebody can pay me in Noble USDC, and then I will cover their Arch transaction fees. So this is quite open-ended. So whichever fee token can be used.
I was speaking more on the entry point. Like, is it restricted to that CW grant entry point, or can I apply it to any entry point? Or do the necessary checks within any entry point?
Yeah, so this is restricted to CW grant entry point. So what happens is when any user gets a contract address as a fee grant, the anti-handler in the protocol side looks to this contract to check if this contract is willing to pay for that person. And so there needs to be like a standardized entry point the protocol can use to check if the contract is willing to pay the fees or not. Okay. So this is something which is decided by the protocol. Yeah.
Okay.
And moving on to the use cases of cwica, one interesting use case is to generate temporary and kind of use and throw addresses for other chains. For example, let's say you're on some Twitter giveaway and somebody's giving away like 20 Osmo and you win this giveaway. But obviously you don't want to give your hard wallet address to this person who's a random stranger on Twitter, but you still want your 20 Osmo. So what do? You can create another new hot wallet on Kepler, but creating another wallet means you have to do the whole mnemonic import. You have to store that mnemonic somewhere. So it is a bit of a hassle. It's not a lot of hassle, but it is a little bit of a hassle. So, and then you do all that, and then you generate your new Osmo address, and then you can share that with whoever is giving you your Twitter giveaway. But then eventually you have to send that back to your main wallet if you want to keep it long term. So this means at the end of the day, your addresses do get doxed. But using cwica, if you create a temporary account on other chains that is not tied with your hardware wallet in any meaningful way. So you have a hardware wallet which uses an Archway account, but you use this to create an osmosis address, and the way it is tied is it's not so if you have people who are like stalking through Mixscan and trying to find out which address is connected to what, this becomes a lot more complicated because now you have to deal with two chains, and also it depends on if there are a lot of such temporary addresses being created, kind of this stalking of an address becomes much more difficult. It's not impossible, but it means you need to have a custom indexing solution. You probably need to run your own nodes to be able to stop somebody like this. This will not be possible to do via Mixscan or any Draw Explorer because it's not just an IBC transaction. It's also, these things are not easily available to be queried on-chain either. So using a cwica, you can create super easy temporary addresses. Like if I want to create a new osmosis address, I don't need to like import a new mnemonic. I just have to like send one registered transaction and that's all. So yeah, that's one of the use cases for cwica in general. And then we can use this to kind of integrate with other chains as well. Like if you already have a DAO on Archway, you can easily use that DAO to like provide liquidity on other chains if that's what you want to do. And you can even do things like autoclaim, osmosis, and P rewards, and basically anything you can do on another chain, you can do from Archway now. And finally, the CW error module. This is very specifically like a developer-focused feature. It does not really have any user-focused use case. Yeah, so that's
Okay. I see that I checked the doc that Sure has sent. I see where it's a more of a technical doc. It points to refining fees and priority and delay queues. So I think maybe the protocol team might take a look at that later.
Yeah, I did go through that. Like I just came through that now, but I think with the way we store callback information is we use the default collections API provided by the SDK, because it is more optimized to be stored as a key value store. And implementing our own data structures to be stored this way will not be super efficient with respect to gas.
Okay. All right. So are there any other questions? Spoorti,
Hey, everybody.
go ahead.
Hi. Just a question about the error handling stuff, and from what I'm hearing here. Could a mechanism be set up with the error handling to make it so that the reliability of the delay more extensively tested for example? Like we have problems that everybody's seeing with stuck packets and that kind of thing. So can that situation, the monitoring of that be improved instead of go out?
Do you see packet headache?
Sorry, I didn't hear it.
I was just, are you talking about the IBC packets which are stuck?
Yeah. So I'm just wondering whether ICA could bring more granularity to that situation, or be a quicker way of them being able to alert the fact that there's an issue on a relay, for example, on a channel, for example. So could a situation be set up, I suppose, where an ICA communication, if you like, using that to maybe do a ping once every half an hour, let's say, for example?
Yeah, you could definitely set it up along with callback as well, so that every once an hour you're trying to do some ICA interaction, and that will in turn check if the IBC channel is alive. And in case the IBC channel is not alive, you will get error of packet timeout, because you provide whatever timeout you want, which you're comfortable with. So that will look into the CW errors module there.
And this will require contract on both sides.
No, the contract's only insist on Archway side.
Okay.
So in case, for example, if Astrovault, if someone is sending tokens from using the Astrovault platform from Archway to Osmosis, for example, they'll be able to track to see whether or not there was a stuck packet somewhere, or that's not possible. Because so we have an issue where a lot of packets get stuck now and then. So from the Archway side, is it possible to track to see if there was actually a stuck packet, or the transfer went through? So the tokens was sent from the Archway wallet to the Osmosis wallet, or it's not possible?
So right now it's not possible, because what you could do is you could have a callback which runs every 10 minutes or so, which tries to fetch all the pending packets. But that would mean that the CosmWasm should have access to read all of these IDC queries. And because of prior issues with CosmWasm Starbase queries not being deterministic, by default, all of the queries are disabled and they are only explicitly enabled. So right now, the IBC related queries are not enabled. But if this is required, that could be looked into, where we do enable the IBC queries so that the CosmWasm contracts can fetch any pending packets. But yeah, that has to be explicitly enabled at the protocol level, and this would require a binary change. It's not just a governance proposal.
Okay. And would that be, so if that was explicitly enabled, would like transactions executed from Osmosis to Archway be accounted for as well, or is it just one way?
Be one way, because if contracts on Archway were aware of the packet from osmosis, then that would mean that the packet already successfully reached our tray.
Okay, yeah, that makes sense.
But I think for the use case of frequent stuck packets, having an off-chain solution might be better because eventually you'll end up paying quite a bit of fees if this is something you're doing frequently.
Okay.
Yeah, that makes sense. I was calling for an off-chain solution before, so.
So the callback module does not do away with the need for external third-party bot scripts then, but it's just a very useful on-chain solution that can circumvent those solutions. But there are still some use cases that might require having third-party solutions, off-chain solutions.
You know, like tracking, I think it's much better. So using callback is ideal for when you want to interact based on that information and not just track something.
Okay. All right, so are there any other questions? I'll take that as a no. Thanks a lot, Spoorti. I think this session was very useful. I'll definitely have the session uploaded to YouTube soon. So, and I'll share it within the builders chat and on Discord. So those who weren't able to join will be able to review. But yeah, do you have an idea when V7 will be put on chain? When the upgrade?
So V7 is already untested right now, so anybody who's interested can play around with this already. And we're planning on creating an upgrade proposal by the end of this week for mainnet. And after 1 week of voting, we should probably go in about 10 days to mainnet.
Okay, sweet. All right. Really looking forward to this. We'll have some documentation prepped, and I'll continuously share stuff on our dev Twitter account as well. So, and I'll start some discussions on our GitHub discussion forum as well, so we can get more insights from the wider community as well. So, yeah, looking forward to that. Okay, so thanks again, Spoorti, and thanks everyone for joining. So this is the end of this builders call. We'll have another call in 2 weeks' time. So everybody will join. I'll see you then.